Last class we completed about the up to applications of Bose model, I think so. Can you see the screen clearly? Okay. And one more time, I am going to revise the few important formulas, and that is radius of orbit. Radius of orbit. What is its formula? The radius of orbit. Radius of orbit Rn equal to 0.529 0.529 into n square by z, n square by z angstroms. Okay, this is radius of orbit. And next one, velocity of an electron. The next important formula is velocity. Velocity of an electron. Velocity of an electron. So what is its formula? Velocity of an electron. The V equal to velocity of an electron equal to 2.188 into 10 to the power of 6 z by n meter per second. If 10 to the power of 8 centimeters per second. Okay. And this is velocity. And next one more, the energy of an electron. Energy of an electron. What is its formula? The energy of an electron. The energy of an electron equal to minus 13.6 into z square by n square. Electron volts per atom. Electron volts per atom. And one more we discussed about the important point is the kinetic energy. Kinetic energy is directly proportional to, inversely proportional to its radius. That means here on increasing radius, what will happen? On increasing radius, kinetic energy decreases. Kinetic energy decreases. And next, potential energy is directly proportional to 1 by minus r. That means on increasing radius, potential energy increases. On increasing radius, potential energy increases. Potential energy increases. And the total energy E equal to, that is nothing but is it directly inversely proportional, and that means directly proportional to 1 by minus r. The finally on increasing radius, total energy also increases. On increasing radius, total energy increases. Total energy increases. Okay, these are important formulas we discussed already. We discussed the important formulas of this. And one more, few important formulas. The conclusion we can say this here from these energies, that is the potential energy equal to, this formula is important. The potential energy equal to minus 2 into kinetic energy. Kinetic energy equal to minus total energy. Okay. And one more, sometimes the potential energy that equal to 2 into total energy. These formulas are important. Now I will give the one question, numerical question based on these formulas. Okay, the potential energy equal to minus 2 into kinetic energy. Okay, the kinetic energy equal to minus total energy, and potential energy equal to 2 into total energy also. I am going to remove this page. Shall I remove it? I will give one question. Is it okay? Okay, I am removing this one. Right. Now write the question based on this. If total energy of an electron, if total energy of an electron, total energy of an electron is minus 1.51 electron volts in hydrogen atom, in hydrogen atom, in hydrogen atom, then find out, then find out, then find out kinetic energy, kinetic energy and potential energy.
అనుకున్న మంచి క్లాస్ వినిపిస్తాను.
Kinetic energy and potential energy. Okay. And next orbit. And which orbit it will be? Orbit and radius, radius and velocity, and velocity of the electron that the orbit. That the orbit. Listen here. The first, actually this is the question. What is that there? If the total energy of an electron is minus 1.5 electron volts, okay, in a hydrogen atom. Now we have to find out the kinetic energy, KEM. This is kinetic energy and potential energy and orbit, radius, velocity of an electron. Okay. Now we are going to calculate first kinetic energy. The kinetic energy equal to, we know that one, minus into total energy. Okay. So that means here what we will get here, minus into minus 1.51. So we'll get here, what we will get, minus into minus plus. So 1.51 electron volts. This is kinetic energy, right? And next to potential energy. Potential energy. Minus 2 into Ke. potential energy equal to 2 into E amma. 2E kada. 2E. So 2 into minus 1.51. What we will get here? 2 into minus 1.51, that equal to minus 3.01 electron volts. Is it clear? Kinetic energy and potential energy. Now energy of, and now what we have to find there? We have to find the orbit, right? Which orbit it is? Orbitum. There we calculated kinetic energy and potential energy. Now orbit. Orbit, to calculate orbit, the energy equal to energy of an electron equal to minus 13.6 into Z square by N square electron volts, right? So their orbit is nothing but we have to calculate this N amma. N we have to calculate here. So energy already they have given. What is its energy? Minus 1.51, that equal to minus 13.6 into Z square here. Z square means the hydrogen atomic number 1 and 1 square by N square. Okay. Now N square equal to shell, that is nothing but orbit. Now do this one. N square equal this question was the N square equal to minus 13.6 by minus 1.51. That equal to how much? That equal to how much, Amma? Then N square equal to we'll get here 9. Very good. That equal to 9. So N square equal to 9. Then N equal to, N is equal to 3 square. That means here 3. So which orbit this is? And this is third orbit. The electron will be there in third orbit. Is it clear? From energy of electron only we can calculate the orbit of the electron present in which orbit. Okay, that is N. And next we calculated kinetic energy, potential energy, orbit, and next radius. Radius. What is its formula? Radius formula. R equal to 0.529 into N square by Z. Angstroms. Okay. So here R equal to 0.529 into N square means which orbit? This is third orbit. So 3 square by Z means 1. Now that equal to how much there? 0.529 into 9. R equal to 0.529 into 9 amma. So we'll get the answer. How much? 4.761 angstroms. 4.761 angstroms. Okay. The next velocity of an electron. velocity of an electron. What is its formula? I am taking in centimeters. Velocity equal to 2.188 into 10 to the power of 8 z by n in centimeters. Centimeter per second. Meter per second means if you take meter per second, 10 to the power of 6 will take, no problem. Both will get the same. In centimeters we are doing. And 2.188 into 10 to the power of 8 into 1 by 3 centimeter per second. Then what is its value? 2.118. If we calculate this one, we'll get here 0.729 into 10 to the power of 8 centimeter per second. This is velocity. And this is radius. And this is orbit. And this is potential energy. And this one, kinetic energy. Is it clear? They have given only the value of total energy. From the total energy, we calculated kinetic energy and potential energy and orbit of the electron and radius of the orbit and next velocity of an electron. Shall I remove this page? I will give one more question for you, and then after I will give the homework. Okay. And next question. Question number 2. Calculate the energy of lithium plus 2 ion for second excited state. Calculate the energy of lithium plus 2 ion for second excited state. What is the formula of energy? What is its formula? The energy equal to minus 13.6 into z square by n square. Here, actually there we have to calculate z. Z is equal to 3. Why? Because atomic number of lithium is 3. Okay. And it's having in the second excited state. Second excited state means what is the n value? Electron exists in second. Electron exists in second excited. Second excited means what is the n value? Can you guess the n value? Second excited means simple. For example, here this is the electron of lithium. This is ground state. And when it will goes to first excited state means next shell, and second excited state means third shell. So here it is n is equal to 1 first shell, and n is equal to 2 second shell, and n is equal to 3 third shell. So this is ground state level. It's going second excited state. Second excited state means what is its n value? The n is equal to 3. Did you understand? Actually, the lithium is a ground state electrons, ground state. The lithium will be for the starting is the ground state electrons. First excited state means the electron will goes to next level orbital, next level orbit. Second excited state means the electron goes to second level orbit. That means this is ground level n is equal to 1, and this is first level the n is equal to 2, and this is second energy, second excited state that n is equal to 3. Okay. And here the n value also 3, and substitute these those values in the formula, and minus 13.6 into z square means 3 square by n square means 3 square. So both will get the cancel. So the answer is minus 13.6 electron volts per an atom. Okay. Okay. Okay, I will give the question for you and try to do this question if you get the free time today or in school, whenever it is. I'm going to give the question. Just homework this is. Calculate the ratio of energies of helium plus for first and second excited state. First and second excited state. Calculate the ratio of energies of helium plus for first and second excited state. Okay. Do this as a homework. Next. The next concept is hydrogen spectrum. Till now we are in Bohr's model only, Amma. These all are comes under applications of Bohr's model only. Okay. Hydrogen spectrum. Keep the heading hydrogen spectrum. Okay. When an electric excitation, first hydrogen spectrum, listen Amma, simple. No need to write now, just listen the concept. For example, when an electric excitation applied on the hydrogen atomic gas, low pressure, actually we have to take the gas of hydrogen. Okay. So if you apply the electric charge on hydrogen atom, if you apply the electric charge on hydrogen atom, it emits the bluish light. Which light it emits? It's bluish light. When this bluish light passed through a prism, actually when the hydrogen, when electric charge apply on gas of hydrogen, it produces bluish light. When this bluish light passed through into the prism, this bluish light passed through into the prism, the spectrum will obtain. Okay, several lines we will get from this one. That is called hydrogen spectrum. The wavelength of spectrum, some are visible, some are IR. Okay, that we are going to discuss. Actually, simply I am saying here, when hydrogen absorb the energy from outside electric charge, the electrons will goes to lower energy level to higher energy level. Amma. lower energy, no need to write this one, just listen. The electrons will goes to lower energy level to higher energy level. Immediately the electrons are unstable in the higher energy level. Immediately these electrons will come back from lower energy level states. Okay, these lower energy level states it will come back from directly or stepwise manner. That was explained by the Balmer scientist. So that is hydrogen spectrum. Okay. Now I will explain. We are going to discuss clearly about this one. Did you keep the heading of hydrogen spectrum? Now write down. When an electric excitation, when an electric excitation, when an electric excitation is applied on hydrogen atomic gas, is applied on hydrogen atomic gas, is applied on hydrogen atomic gas at low pressure. At low pressure, a bluish light is emitted. A bluish light is emitted. A bluish light is emitted when a ray of this light, when a ray of this light, when a ray of this light is passed through a prism, is passed through a prism, is passed through a prism, a spectrum of several isolated a spectrum of several isolated sharp lines is obtained. Isolated sharp lines is obtained. Sharp lines is obtained. The wavelength of various lines, the wavelength of various lines, the wavelength of various lines show that spectrum lines line visible. Spectrum lines lie in visible. Ultraviolet, visible, and ultraviolet, that means UV, infrared, IR region. Okay. These lines are grouped into different series. These lines are grouped into different series. Okay. Now I will give the different series of these lines. I am removing this one. Shall I? These different series are here. Here series and discovered by and regions and n2 minus n1 take it screenshot faster. And n2 minus n2 and n1, not minus, this is n2 and n1, and number of lines. Here series is the first one is Lyman series. Lyman, and it was discovered by the Lyman scientist. And this region is UV region. Write it fast, Amma. We don't have time. And here the n2 equal to, it may be 2, 3, 4, etc. And n1 is 1 only. And the number of spectral lines are n2 minus 1. n2 minus 1. Okay, n2 3 aయిందనుకో, the number of spectral lines are 2. Okay, and next to Balmer series. Balmer, the scientist name Balmer only, and this is a visible region. Visible, and here the n2 3, 4, 5, etc. And the n1 is 2 and n2 minus 2 Amma, spectral lines. And next to fashion, PASCHEN, fashion, and this one also discovered by the fashion. And this is infrared, IR, infrared region. And here n2 is 4, 5, 6, etc. And n1 equal to 3. And here n2 minus 3 Amma. And bracket series. Bracket, and the scientist name also same bracket. And here region is a higher region only. Higher, and here n2 is 5, 6, 7, and n1 4, and here n2 minus 4. Okay, the session will end, Amma. If it end, we'll continue tomorrow, no problem. After bracket, fund, and then after Humphrey. These both scientists are same only, Fund and Humphrey. And here both are IR region only. Here IR, here also IR, and that too for